Welcome to Math with Miss Garrity. I'm going to talk about looking at numbers where there are radical signs in the denominator. And to simplify that, we are going to rationalize the denominator. Now in math, with equations, we have to keep the equation each side balanced. Here, we don't have an equation. I have a fraction. And I'm trying to change this fraction so that the denominator does not have a radical sign in it. Well, I can do that, but I can't change the value of my original fraction. So what we can do is we can multiply this fraction by the number 1. Because when you multiply by 1, you don't change the value of the original number. The multiplicative identity property. So we're going to be very creative in rationalizing the denominator, and we are going to multiply by the number 1, but that number 1 is going to change. If we take radical 5 over radical 5, that has a value of 1. So I can multiply that by this fraction and not change any value. Radical 5 times 2 would be simplified as 2 radical 5. Radical 5 times radical 5, well, it actually is radical 25. But we know the value of radical 25 is simply 5. And I've done it. 2 over radical 5 is equivalent to 2 times radical 5 over 5. And if you divided this and used a calculator, you would get the exact same approximation as if you took 2 times radical 5 and then divided that by 5. So rationalizing the denominator is getting the radical sign out of the denominator. Let's try another one. Let's take 1 over the square root of 2. I'm going to multiply that by the number 1, which in this case is disguised as radical 2 over radical 2. And the answer, the simplified, rationalized denominator answer would be radical 2 over 2. We can have fractions that maybe have expressions in the denominator. And if the expression has a radical sign in it, that's not considered rationalized. What we're going to multiply by is we're going to multiply by 1. But in this case, we're going to rewrite the denominator with the opposite sign. So I'm going to multiply by 1 minus radical 2 and 1 minus radical 2. Now, you'll notice this is getting kind of complicated. We're multiplying here. And we multiply our fractions by multiplying across the numerator, but we have these two terms. It's basically a binomial. So we are going to distribute the 3. 3 times 1 is 3. 3 times negative radical 2 is minus 3 radical 2. I just distributed the 3. Now over here, we've got a binomial times a binomial. So we're going to FOIL. I'm going to take 1 times 1. Then I'm going to take the outer, 1 times negative radical 2. Then I'm going to multiply radical 2 times 1. Then I'm going to multiply the last together, minus radical 4. So let's simplify this fraction. Well, the numerator cannot be simplified. So I'm going to leave that as is. But if you look at the denominator, Negative radical 2 plus radical 2 cancels. And we've got minus radical 4. Well, that's the same as saying minus 2. So the denominator becomes negative 1. And we've just changed 3 over 1 plus radical 2. We've multiplied it by 1. And so we have an equivalent expression. We could actually divide each of these terms in the numerator by negative 1 to simplify it even more. And there you go.